Welcome to the next lecture on screw thread metrology. First, we should understand what is the necessity for this screws, okay, screw thread. So, basically this thread which is used here in this bolt, this thread here which is there, this tries to give me a flexibility in making temporary assemblies. So, I wanted to assemble two pieces, I will use this bolt and then either I can directly fasten it to the plate or I can put a nut on the other side and try to use for fastening. So, this is used for temporary fastening or temporary assembly. So, this is required because wherever I wanted to create a very complex geometry, I will not be able to do it in a single piece. I do it in multiple pieces, either I glue it or I do this fastening attachment and try to make a complex structure. This complex structure may be due to the limitation I do not have a large bed. So, then that is one. Second thing is I frequently have a wear and tear of parts. So, I need to open the assembly, replace it and then go ahead with the product. So, there also I use this temporary fastening techniques like screw threads. And if you look at it, these screw threads, you should understand it is not like a standard flat shaft. So, a standard flat shaft, it is easy to measure the diameter. Here it is a thread which runs. So, you have a peak, you have a valley. So, now when you try to measure the distance, if you try to measure from here to the next pitch, maybe there will be a variation. Or if I try to put a flat plate on a line, there might not be a perfect flatness in contact. So, the standard measuring devices cannot be used. Okay. And here you see that I have put different types of screw threads M6, M4, M5, M8 and M3. So, this clearly tells me, these are taps basically, this clearly tells me that these are referring to some scale and this scale is a standard scale. So, this gives me the freedom of interchangeability. So, we studied in this course initially what is the need for interchangeability. So, for maintaining the interchangeability concept, we need to have a standard. So, M3, M4, M5, M6 and M8, these are various types of taps which are available in the market today. By using these taps, you create a thread. So, these thread follow an international standard. Okay. So, let us see what all are we going to cover in this lecture. So, we will try to cover what are the measurements for screw threads. Then some of the terminologies, screw thread metrology terminologies we will see. Then measurement of screw thread elements we will see. Then thread gauges we will see, and then we will try to see how do we measure pitches. So, what is the need for understanding gauges? So, these gauges, thread gauges means here it is something like a go or no go gauge, we will try to use it. So, yes, no. So, we can use this thread gauge, but if we want to do measurements, then we will undergo various elements in measurement. And finally, pitch. Measurement of screw threads. Screw thread geometry has evolved since the early 19th century. The Whitworth thread system, proposed as early as 1840, was the first documented screw thread profile that came into use. So, that was the time when industrial revolution started. So, big machines were started getting built. So, and lot of these machines had lot of mechanical moving parts which had wear and tear. So, people were looking at some fastening techniques which can be used so that they can have maintenance. A couple of decades later, after this industrial revolution or during the time of industrial revolution, the cellar system of screw threads came into use in United States. Both these systems were in practice for a very long time and laid the foundation for more comprehensive unified screw thread system. Because in the world, if you see, there are certain countries which follow inches scale, there are certain countries which follow millimeter scale, right. So, inches and millimeter, there is always a difference. So, if you want to have a standard and then across the world you have to start supplying your parts, then people said that okay, from inches let us move to millimeter. So, this is now a unified standard. So, we start using this millimeter standard, millimeter units for the screw thread. So, screw thread gauging plays a vital role in the industrial metrology. In contrast, to measure the geometric features such as length, diameter, screw thread measurement is more complex. So, if you take as such, this is a shaft. So, if you want to measure the dimension of this shaft, so what you do is we try to talk in terms of length and then we try to talk in terms of diameter. But when you try to have a screw thread on top of it, the complexity increases. That is what we are trying to say. We need, so what are the complexities? We need to measure the interrelated geometric aspect such as pitch, diameter, lead, helix, flank angle and many other things amongst them. So, in the next slide we will see what are these things. So, here I have listed the legends. So, from this you can try to read this figure. So, let us go step by step. First one we will try to take pitch. So, what is pitch? If you try to measure the dimension between two peaks, successive peaks in a screw thread, this is called as pitch, right. This is called as pitch. So, pitch can change depending upon your requirements. You can have a smaller pitch, you can have a larger pitch. That means to say, if the pitch is large, so then that number of threads are going to be less. So, here the pitch decision is taken based upon the loads which come into effect and also the diameter. Okay. So, this is pitch. Next one is going to be major diameter. So, major diameter happens between this point and see, if you see that there is a crust, right, here is a crust. So, from the topmost point, if you try to take to the opposite side topmost point, so that is called as the major diameter. So, major diameter. So, next one is going to be minor diameter. Minor diameter is going to major diameter, minor diameter. Minor diameter is going to be from this point, right, from this point to the outside. So, from here it goes to here. So, this will be the minor diameter. And what is pitch diameter? Pitch diameter is from center of the coaxial of the axis, you will see, to this point, we call it as the pitch diameter. Okay. What is a pitch line? The line passing it, almost pitch line is nothing but the axis line is called as the pitch line, the axis of the screw, the center portion of it. Then we will try to see what is addendum and we will see what is dedendum. Addendum means from the central axis to the crest, it is called as addendum. From here to here, from the central axis to this is called as addendum. So, what is dedendum? From the central axis to, you try to imaginarily make a cusp, right, or make a truncation of the cone. So, till then it is called as dedendum. Okay. So, depth of the thread will be from the topmost portion to the bottommost portion, from one thread to the next. So, one crest to the valley. So, that is called as the depth of the thread. And here this angle between two flat planes at an angle, so that is called as angle of thread. This portion is called the angle of thread. So, you have flat plane. So, this flat plane is trying to make an angle. So, it is called as angle of thread. So, what is flank angle? With respect to the thread here, you try to take one between the plane and the central axis of the single thread, it makes a flank angle. Okay. So, then we will try to see what is apex. So, if you try to draw and if you try to extend the flat plane and if it meets at a point, so that point is called as the apex, right. In the same way, in the bottom wherever it meets, it is called as the root. So, this portion where it is touching the imaginary line, it is called as the crust. So, crust happens on the top, root happens at the bottom. Crust on the top, root at the bottom. So, what is left is the angular pitch. So, angular pitch is nothing but which covers from the imaginary down point of this extended thread to the topmost point is called as the angular pitch. So, these are some of the terminologies which are used when you have to measure these terminologies apart from the shaft diameter and the length when you talk about threads. So, screw thread terminologies is slightly different, but generally what we more talked about is the pitch, and then we talk about addendum, dedendum, depth of thread and angle of thread. So, angle of thread is when there is a single thread, the angle which is subtended is called as theta, and when it is with respect to axis, central axis, this becomes alpha. So, now let us see the individual explanations. Screw thread. AS, the American Society for Tool and Manufacturing Engineering, ASTME, defined a screw thread as following. Screw thread is the helical ridge produced by forming a continuous helical groove of uniform section on the external or internal surface of a cylinder or a cone. Okay. Is the helical ridge. Helical ridge, this is helical, right. So, when it is helix, this is helix, right. Helical ridge produced by forming a continuous helical groove, continuous helical groove. So, this is a groove, okay, this is a groove. So, this is a groove, a depth which is given. Helical groove of uniform cross section on the external and internal. When you talk about bolt, it is external. When you talk about nut, it is internal. Screws will have external, okay, nut is internal. Surface of a cylinder or a cone, that is the screw thread. Form of thread, it is the shape of the contour of one complete thread as seen in an axial section. Form of thread, it is the shape of the contour of one complete thread as seen in an axial section is the form of thread. Some of the popular threads formed are British Standard Whitworth. Whitworth is one standard, American Standard, then British Association, Null, Buttress and Unified, Acme. So, Acme is the most common thread which is used today, but we still have Whitworth, American Standard, British Association, Knuckle and then Buttress, Unified and Acme. External thread and internal thread. The screw thread formed on the external surface of a workpiece is called as external thread. For example, bolt, stud, these are external threads. When we talk about internal threads, the screw thread formed on the internal surface of the workpiece is called as internal thread. For example, in a nut. Okay. What is the axis of the thread? It is otherwise called as the pitch line. If you go back and see the definition, pitch line. So, pitch line is nothing but the axis of the thread is called as the pitch line. So, axis of the thread, it is the imaginary line running longitudinal throughout the center of the thread is called as axis of thread, which is nothing but pitch line. Next one is fundamental triangle. This is the fundamental triangle. So, it is the imaginary triangle that is formed when the flank are extended till they meet each other to form an apex or vertex. So, what will happen generally in a screw thread? It will be something like this. This will be a screw thread, but if you try to project it, it forms a fundamental triangle. It is an image. So, if it can go like this. Okay. This is your alpha, this is your theta. It is the imaginary triangle that is formed when the flank, this is called as a flank. Okay. Flank are extended till they meet each other to form an apex or a vertex. Angle of thread. This is the angle between the flank of the thread measured in the axial plane. This is the angle between the flanks, theta. If you go back, look at it, theta. Theta is nothing but angle of thread. This is a flank, I said a plane, this is a flank, this is a flank. Between these two flanks, the angle which is subtended is called theta, which is the angle of thread. All these parameters have to be measured. Next, flank angle. It is the angle formed between a flank of a thread and a perpendicular to the axis. Suppose you have something like this, right, between the perpendicular line and the flank alpha, it is nothing but alpha. It is the angle formed between a flank of a thread and the perpendicular to the axis of the thread that passes through the vertex of a fundamental triangle is called as flank angle. If you go back and see, alpha is the flank angle. So, this is a triangle. So, this is the fundamental triangle, this is the original surface. So, if you try to draw a imaginary perpendicular with respect to this angle, it is called as flank angle. Then what is pitch? Pitch is the distance between two corresponding points on adjacent threads measured parallel to the axis of thread. So, it is the distance between, okay, it is the distance between two corresponding points on adjacent threads, okay, measured parallel to the axis of the thread is called the pitch. What is lead? It is the axial distance moved by the screw when the screw is given one complete rotation about its axis is called as the lead. For example, you have a shaft or you have a screw, then you have a nut. This nut is rotated. So, it is the axial distance moved, it is the axial distance moved by the screw when the screw is given one complete revolution about its axis is called the lead. Then lead angle, it is the angle made by the helix of the thread at the pitch length with a plane perpendicular to the axis. Helix angle, we have already seen, it is the angle made by the helix of the thread at the pitch line with the axis. This is and it is measured on an axial plane. Then we will try to see what is major diameter and minor diameter. Major diameter, in case of external thread, the major diameter is the diameter of the major cylinder which is coaxial with the screw and touches the crest of an external thread. So, if you go back, so major diameter is 3, okay, this is 3. So, an imaginary, let us see the definition. It is the major diameter, the diameter of a major cylinder which imaginary which is coaxial to the screw and touches the crest. Coaxial to the screw and which touches the crust. So, this is the coaxial to the screw and touches all the crust is called as major diameter. When we talk about minor diameter, in case of external thread, minor diameter is the diameter of the minor cylinder which is coaxial with the screw and touches the root of an external thread, which touches the roots of an external thread, is called as minor diameter. So, for internal threads, it is the diameter of the cylinder that touches the crust of the thread. This is for internal and that is for external. Please this is very important. When a definition is asked in the examination, you can always say the major diameter I can ask in terms of with internal threads touches the crest of the thread. So, this is called the root diameter. Effective diameter or the pitch diameter, it is the diameter of a pitch cylinder which is coaxial with the axis of the screw and inserts the flank of a thread in such a way as to make the width of the thread and the width of the space between them equal. In general, each screw thread is specified by an effective diameter or a pitch diameter as it decides the quality of the fit between the screw and the nut. So, this is also very important. In general, each of the screw thread is specified by an effective diameter as it decides the quality of the fit between the screw and the nut. So, this is also a very, very important point. So, please keep this in mind. When it is major diameter or minor diameter, it will be both. When it is external thread, internal thread, it will be root and crust, that is the difference. And here, if we want to talk about the fit which has to happen between the screw and the nut, then pitch diameter plays a very, very important role. So, all these things are defined in this geometry. Pitch diameter is also defined. Pitch diameter is 4. So, this is the pitch diameter. Okay. Minor diameter, this is the minor diameter between the crest and the tuft. So, there can be single start thread and multiple start threads. In case of a single start thread, the lead is equal to pitch. What is the lead? Lead is I rotate the screw or I rotate the nut. What is the advancement it has is the lead, okay, is equal to the pitch. What is pitch? The distance between two consecutive threads is the two consecutive peaks or two consecutive valleys in a screw is called a pitch. So, if it is a single thread, then the lead will be equal to pitch. So, that means to say I know if I rotate it by one pitch, the lead will be equal. For example, if you attach a motor, right, and then you attach a screw to it. So, the motor rotates, right, this is a motor, this motor rotates and this is the screw, and on top of it if you have a table which is attached. Now, for what rotation of this table will the screw advance or the table move? Okay. So, this is the lead what for one rotation, what is the lead? It is equal to the pitch, that is what we are saying. Therefore, the axial distance moved by the screw is equal to the pitch of the thread. So, this is an important parameter. So, we have it. There are also multiple start threads. So, multiple start threads are the lead is an integral multiple of the pitch. Accordingly, you can have double start, triple start depending upon your requirements. A double start will move by an amount equal to 2 pitch length for one complete rotation of the screw. So, you can also have double start, and generally what you have on top of a lid and then you have a bottle, they will always have a multiple start. So, you can try to fasten just by rotating half, you can try to lock the bottle. So, we will always have a multiple start thread in a plastic bottle with a lid, we will have multiple, and single start is generally in a nut bolt, we always have a single start. Multiple start, for special application you can also have multiple start threads. Please understand there is a difference between single start and multiple starts. Okay. So, what are the elements, screw thread elements which are to be measured or which is easy to measure? Major diameter, minor diameter, effective, pitch, angle and form of threads are very important. Form of threads, Whitworth thread, Acme thread, these are different forms of threads. So, these are the 5 elements or 6 elements which are there in a screw which has to be measured, so that we evaluate the performance of screw and nut when they are in mating. So, internal surface, external surface. First, let us see how do we measure the major diameter. The simplest way of measuring a major diameter is to measure it using a screw thread micrometer. Screw thread micrometer, generally what we do is we take a screw thread micrometer, and here we have a fixed one and here we have a moving one. So, we try to change the contacting point . We try to change the contacting point so that the screw threads exactly mate with the anvil threads, so that you can try to measure the diameter. However, for a more precise measurement, it is recommended to use a bench micrometer, which we saw what is a bench micrometer. The major advantage of bench micrometer is that a fiducial indicator is part of the measuring system. It is thus possible to apply a pressure already decided upon by referring it to the indicator, fiducial indicator. The machine is essentially used as a comparator. We covered this topic under the comparator. In comparator, when we finished vernier caliper, screw gauge, we also studied about the bench micrometer, which is very important. Bench micrometer is predominantly used to measure the major diameter of screw threads. So, you have this fiducial indicator which is there. Then how do we measure the minor diameter? The best way to measure the minor diameter is to measure it using a floating carriage micrometer. This also we saw when we studied about the comparator. The minor diameter is a measure by a comparative process wherein small V pieces that make contact to the root of the threads are used. The selection of V piece should be such that the included angle of the V piece is less than the angle of the thread. So, major diameter, minor diameter can be measured by floating carriage micrometer and the bench micrometer. These two are comparating devices. With this, you can try to measure the major and minor diameter. So, if you go back and look at this, this is the fiducial indicator. You have a clamp. So, here is a clamp which is maybe one we can take it as dead center, the other one we can take it as a live center. We move this, put the screw thread here, and then between these two clamps we hold it, and that this is seen by a micrometer reading what is the thread major diameter reading of it. Major diameter and minor diameter can be measured. The effective diameter, which is otherwise called as the pitch diameter, is very important, and this has to be measured. So, a thread measurement is always conducted by a wire method, which is very simple and popular. What is a wire method? Between two threads, you just put a wire and then start. So, you have a thread. So, now what you do is you have a suppose you have something like this. So, you put one more wire. So, now you know the diameter of the wire, and so now you measure that the diameter here, and then you know the wire diameter. From this, by trigonometrical calculations, we can try to figure out what is the effective pitch diameter. So, if you go back and see what is the effective diameter in this diagram, the 4 is the pitch diameter which we are interested to measure, or the effective diameter. So, there are 3 methods. One is called as one wire method, 2 is called as 2 wire method, and the third one is called as the diameter of the best size wire. Now, the next topic of discussion is going to be measurements of screw thread elements. So, here there are 3 types of methods. One is one wire, 2 wire, and the best size wire. So, one wire method, this method is used if a standard gauge of the same dimension as the theoretical value of the dimension over wire is available, then we go for this measurement. So, here the micrometer is readings are taken at 2 or 3 different locations, and the average value is taken. So, generally in metrology or in even measurements, any measurements, what we do is we ask them to repeat the process, and when you repeat the process, we get 3 or 4 set of data. Then what we do, we try to find out the standard sigma, standard deviation, and the mean, try to figure out what is the process variation, and then try to choose the method what we want. So, here also what we do is we try to take 3 readings and then we try to take the average value of it. So, this value is compared with the value obtained with the standard gauge. The resulting difference is a reflection of the error in the effective diameter of the screw. So, how do we figure out? This is the effective diameter of the screw. So, here there are 2-3 parameters which I have to describe. First one is called as M. M is nothing but the distance over wires. The effective diameter DE is the effective diameter. And T is the dimension under the wire, and P is the correction factor. Okay. So, we have to find out this P for various methods. So, if we wanted to measure T, T is the dimension under the wire, T is nothing but M minus 2D, okay, where D is equal to diameter of the best wire. Fine. So, when we use two wire method, this will be more easily understood. So, what we are trying to say is, in the two wire method, okay, so basically this was single wire. When we try to take a two wire method, okay, so here you try to keep one wire, and in the opposite side you keep one wire, and then what we do is we try to put the screw gauge, and here it is a perfect contact. Okay. So, the distance between this to this is called as M. Okay. The distance between the center of this and center of this is called as E. Okay. In a two wire method, this is a two wire, the two wire method, the diameter are identical. You can't take varying diameter, and then what we do is these two identical diameters are placed and they have to be in contact with the screw thread. So, if we wanted to find out the P, so what we do is, okay, so I will go to this diagram. So, then here I will try to derive the entire thing. So, if we want to find out the equation, so here what we do is we try to take a triangle OFD, triangle O, F and D. This triangle is nothing but OF is equal to D by 2 cosecant x by 2. Triangle ODF, this can be represented as D by 2. Okay, what is D? D is the wire diameter, x by 2. So, if we want to find out FA, Fa is nothing but d by 2 cosecant x by 2 minus d by 2. So, what is Fa? Fa is nothing but d by 2 cosecant x by 2 minus small d by 2. Okay. So, this in turn can be represented it as d bracket cosecant x by 2 minus 1 divided by 2. I think here it is d. So, it is this, and then Fg, if you want to find out Fg, what is Fg? Fg is F and you get G, right. If you want to find out Fg, it is nothing but Gc cot x by 2, which is nothing but P by 4 cot x by 2. Okay. So, here we should understand BC is equal to pitch, okay, by 2 and GC is equal to pitch by 4. Therefore, AG equal to FG minus FA, which will come to P by 4 cot x by 2 minus D cosecant x by 2 minus 1 divided by 2. Okay. So, after this since AG accounts for the correction factor only on one side of the screw. So, we have to multiply 2 times multiply by 2 in order to account for that on opposite side. So, now P is equal to 2 times AG, which is nothing but P by 2 cot of x by 2 minus D cosecant x by 2 minus 1 will be there. So, although it is possible to measure the value of m, we measure m, the distance between the wires, using micrometer. This method is prone for error. So, although we measure it, we still have errors. We still have error in this method. Okay. So, here let me go back, and it is d by 2 minus 1. So, this is for a 2-wire method. We are trying to find out this P. So, the P is nothing but the correction factor. So, now where is this correction factor used? So, this is the effective diameter is equal to theoretical dimension of the dimension of the wire, and P is the correction factor with this. So, T plus correction factor, we get the effective diameter. So, this method also has an error. So, let us look at the best wire method, which is this method, which is called as the best wire method. So, in best wire method, what we do is we try to find out this D. So, what is this D? D is nothing but the diameter is D of the wire, and then what we do is we try to put the wire such that it comes in contact with the flank along the pitch line. So, when you try to take the triangle OAB, we get it as triangle OAB, we get it as sin AOB is equal to AB by OB, that is sin 90 minus x by 2 will be equal to AB by OB, or OB equal to AB sin of 90 minus x by 2. So, which is nothing but AB by cos x by 2, and this is nothing but AB secant x by 2. Okay. So, the diameter of the best wire is equal to 2 times OB. So, that is nothing but 2 times AB secant x by 2. Okay. So, from the this can be find out AB is nothing but P by 4, where P is the pitch. Okay. So, pitch of the thread. So, finally, what we get is D, which is nothing but P by 2 into secant x by 2. This is the relationship we have written it earlier. Okay. This is the diameter of the best wire method. You try to get the diameter. Fine. So, this is what x by 2. Okay. So, we will try to do a problem and then we will try to proceed. So, it is required to measure the effective diameter of a screw using a 2-wire method. The distance across 10 threads measured using a scale is 12.5 millimeter. Determine the size of the best wire for metric thread. So, here what was given is a pitch equal to 12.5 millimeter for 10 threads. So, that is nothing but 1.25 millimeter will be the pitch. So, what is the effective best wire method diameter? Diameter is nothing but P by 2 into secant x by 2, which is nothing but where x equal to 60 degrees for metric thread. Each thread it is different. So, for metric thread it is 60 degrees. So, what we do is we try to take P is nothing but 1.25 by 2 into secant 60 by 2. Okay. So, this is equal to 0.722 millimeter. This will be the size of the best wire of a metric thread used. Okay. So, this is done by 2-wire method. So, the best diameter wire is taken, and then we are also trying to take the 2-wire method, what is the pitch. So, next is 3-wire method. So, in the 3-wire method we have this is E and this is your measured one. So, you have 2 wires on one side and 1 wire on the other side, we try to measure it. So, if you want to calculate E is nothing but M minus D, D is the diameter of the wire, cosecant x by 2 plus P by 2 cot x by 2 minus D. So, this derivation you can derive it from this equation. We will try to give this complete derived equation in the study material, but I would request you guys to solve this and see. So, if we can try to find out E equal to D. So, this will be the E is nothing but the effective diameter. Okay. So, here is a figure, we have used 3-wire method to calculate this. So, let us try one problem and see here. A metric screw thread is being inspected using a 2-wire method in order to measure its effective diameter, and the following data is generated: pitch equal to 1.25, diameter of the best wire equal to this much, and the distance over the wire is this much. Determine the effective diameter of the screw thread. So, effective diameter is nothing but dE equal to T plus P, where T is the dimension under the wire and P is the correction factor. Okay. T equal to M minus 2D and P is equal to P by 2, this correction factor P by 2 into cot x by 2 minus D cosecant x by 2 minus 1. Okay. So, therefore, when you solve, put all the equations, P equal to 1.25 divided by 2 cot 60 by 2 minus D, D is 0.722 cosecant 60 by 2 because it is metric minus 1. Okay. This is nothing but 0.3605 millimeter. So, T, the theoretical value is nothing but 25.08, the distance over the wire, minus 2 times D 0.722, okay, which is equal to 23.636 millimeter. So, finally, DE is nothing but T 23.636 plus 0.3605, which is nothing but 23.9965 millimeter. So, in this, what we have done is, we know the effective diameter is nothing but dimension under the wire plus correction factor. Okay. And this small p, okay, let me now put it like this so that you will not get confused. This is P and this is the correction factor. So, let me correct it. This is a small p. So, then this will be the small p, pitch by 2. This is pitch, small p, and here again pitch of the thread P, P is D by 2 is P. Okay. So, this is small p is the pitch and big P is the error. Okay. Next is measurement of pitch. So, till now what we saw, major diameter measurement, then minor diameter measurement, then we saw effective diameter measurement, then we are going to see the pitch measurement techniques. Measure of pitch is done by progressive pitch error. This error occurs when the tool work velocity ratio is incorrect but constant. So, this is progressive pitch. Okay. After measuring the major diameter, minor diameter and the effective diameter, the next topic of discussion is going to be the pitch error. The error is pitch and the thread angle, the error in pitch and the thread angle also cause the progressive tightening of the mating surface due to the interference of the flank surface. So, that means to say, between these two surfaces, if there is an error, so then these are the flank surfaces, right. So, when there is an error, so this error is called as pitch error. The pitch error are due to improper ratios of cutting tool velocity to the rotating velocity of the workpiece. So, it is improper ratio of cutting tool velocity to rotating velocity of workpiece. This is the improper ratio. Okay. The pitch error can be classified into three. One is called as progressive pitch error, next is called as periodic pitch error, and the third one is called as irregular errors, which is called as drunken thread error. So, progressive pitch error, this error occurs whenever the tool work velocity ratio is incorrect but constant. It will be incorrect, what do you want, but it will be constant. Generally, it is caused by the pitch error in the lead screw of the machine. This is called as progressive pitch error. Other factors contributing to the pitch error are an inaccurate gear train or an approximate gear train. So, if there is the gear train is nothing but the two gears, then this in turn transmits to this in turn transmits to this, a series of gears which are in mesh with each other, either for reduction or increase in torque. We call it as gear train. So, next one is called as periodic pitch error. This error occurs when the tool work velocity ratio is not constant. In the previous one, it is constant, but it is incorrect. Progressive pitch error is constant but incorrect. So, what is constant? Tool work velocity. Okay, constant for progressive. In periodic, it is not constant. The contributing factors are pitch error in the gear train and or axial movement of the lead screw due to the worn out through the thrust bearings. We always will have periodic pitch error. The drunken error, this results in periodic error creeping in at intervals of one pitch. The pitch measured parallel to the thread axis will be correct, but the thread are not cut to the true helix angle, then you have a drunken thread error, or it is otherwise called as irregular error. This error does not pose a serious problem for the functioning of a screw, but may result in a noticeable error when using a large diameters. Okay. This is a pitch measuring machine. So, here what we are trying to do is we are trying to measure the pitch and we are trying to quantify the error. So, the next one will be thread gauge. Thread gauge or of screw threads is a process for assessing the extent to which the screw thread conforms to the specific limit of the size. So, you already have a gauge. So, this gauge is allowed to see, you just place this on top of the screw and then see screw threads and see how much it is perfectly setting. The thread gauge are classified on the basis of following criteria: classification of thread gauge based on type of application, classification of thread gauge based on their forms. Classification of thread gauge based on type of application: working gauge, inspection gauge, master gauge. So, this we studied in the beginning, what are these working, inspection and then masters. Then the classification of thread gauge based on form, you will have a plug screw gauge or a ring screw gauge to find out. So, again here these gauges will try to have follow Taylor's principle for go gauge and no go gauge. A go gauge should check both sides and the geometric features and thus must be in full form. A no go gauge should check only one dimension at a time and it will be short. So, that is how by looking at the go gauge, no go gauge, you can try to figure it out. So, you can have working gauge, inspection gauge, master gauge based on the application, and when the classification is based on the form, it can be plug type and ring type. Plug type means if there is a nut, it is plug type. If there is both can be used, plug and ring can be used here. Plug screw gauge, a straight thread plug gauge assures the accuracy of the basic element of a screw thread, namely major diameter, pitch diameter, root clearance, lead and the flank angle. A taper thread plug gauge checks in addition to all these elements taper also, as well as the length of the front end to the front end to the gauge notch. So, it checks all these dimensions in the taper, and when you talk a plug, it talks about major diameter, pitch diameter, root clearance, lead and flank angle. The ring screw gauge, they are used to check the external thread form like bolt, ring, external. Okay. Like bolt. Similar to plug gauge, a system of limit gauge is provided by the full form of go gauge and not go gauge to check the effective diameter. So, we will have plug gauge, screw gauge as well as ring screw gauge for measuring. So, when we try to recap, we have the following points. We first saw the introduction of measuring screw thread, then we saw terminologies, then we saw various thread elements, then measurement of screw thread elements, major axis, minor axis measurement, type of gauges, then plug screw gauge and ring screw gauge. With this, we come to an end for this chapter. Thank you.